Hi, welcome to this session on Mathematics, Chapter 2 on Polynomials. For Class 10 or Grade 10, we are doing division algorithm for polynomials, and we are covering in this session exercise 2.3, question number 3. Question number 3 states that obtain all other zeros of polynomial 3x raised to power 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are square root of 5 by 3 and minus square root of 5 by 3. We note that degree of this polynomial is 4. Therefore, the maximum number of zeros that this polynomial can have is 4. Also note that if a minus b and a plus b are factors of a polynomial, then the multiplication of these two factors, that is multiplication of a minus b and a plus b, will also be a factor of the polynomial. And we know that multiplication of a minus b and a plus b is equal to a square minus b square. Therefore, we can say that a square minus b square is also a factor of the polynomial. So now let's start by writing our given polynomial as px, so that px is equal to 3x raised to power 4 plus 6x cube minus 2x square minus 10x minus 5. And if the square root of 5 by 3 and minus square root of 5 by 3 are zeros of the polynomial px, then x minus square root of 5 by 3, and here we are getting square root of 5 by 3 from here because that is one of the zeros. We can say that x minus square root of 5 by 3 and x plus square root of 5 by 3 are factors of polynomial px. This means that the multiplication of these two factors, that is x minus square root of 5 by 3 multiplied by x plus square root of 5 by 3, which is equal to x square minus 5 by 3, is also a factor of px. So now we know that x square minus 5 by 3 is a factor of px. So let's divide the given polynomial px by this factor x square minus 5 by 3, and then we should get the remainder to be equal to 0 because x square minus 5 by 3 is a, let's say, proper factor of polynomial px. Okay, so now that we are dividing polynomial px by x square minus 5 by 3, and the steps to carry out that division are shown here. We have the factor here x square minus 5 by 3 written here. We have added a term 0x so that spacing is very easy during the division process. And we get the quotient as 3x square plus 6x plus 3. And we know that dividend is equal to divisor into quotient plus remainder. And in our case, we have gotten the remainder as 0. And we have gotten the quotient as 3x square plus 6x plus 3. And this is here. So we write this quotient here. And the divisor in our case is x square minus 5 by 3. So here we have now gotten px is equal to x square minus 5 by 3 into 3x square plus 6x plus 3. So we can further simplify by taking 3 common from the second factor. We get px is equal to 3 multiplied by x square minus 5 by 3 into x square plus 2x plus 1. Now if we start simplifying the last factor, that is x square plus 2x plus 1, we can further write px is equal to 3 into x square minus 5 by 3 into x square plus x plus 1. And you would notice that here these two first factors are as it is from the previous step, and here the last factor we have simplified further, and we have written x square plus 2x plus 1 as x square plus x plus 1. So this will help us write px to be equal to 3 multiplied by x square minus 5 by 3 into x plus 1 whole square. Now if we have to make this px is equal to 0 to get the additional zeros that we have to find out, we can try to equate different parts of the right hand side equal to 0. So first is that when 3 is equal to 0. When 3 is equal to 0, then the entire polynomial px will become 0, and hence we can say that the 0 of the polynomial is 3. but we know that 3 is not equal to 0, so we do not consider this factor. So let's move on to the second part. The second factor on the right hand side is x square minus 5 by 3, and if we make this equal to 0, the entire polynomial px will become 0. So let's see what is the value of x when this factor x square minus 5 by 3 becomes 0. We see that when x is equal to square root of 5 by 3 or x is equal to minus square root of 5 by 3, this entire polynomial px becomes 0. So we can say that x is equal to square root of 5 by 3 and x is equal to minus square root of 5 by 3 are zeros of the polynomial. This is true, but these are the zeros which we have already been given in the question. So that is not our objective. Our objective is to find the additional zeros. So let's move on to the third part or the third factor of the right hand side, and we see that this entire polynomial px will be equal to 0 when x plus 1 whole square will be equal to 0, and this will be equal to 0 when x is equal to minus 1, and x again we are writing it twice because there is a whole square. So when x is equal to minus 1, then this whole factor x plus 1 whole square will become 0, and hence at that time px will be 0. So we can say that x is equal to minus 1 and x is equal to minus 1 are the two additional zeros that we were set out to find of the given polynomial. Hence we can write all the four zeros of the given polynomial. The first zero is square root of 5 by 3, the second zero is minus square root of 5 by 3, and the next zero is minus 1, and the next zero is minus 1. So we can say that we have found the zeros, the additional zeros of the polynomial as minus 1 and minus 1.